Howdy, everybody. Good to, so to speak, see you all here again.
Yeah, how
Glad
we all
you're all
doing
here.
there, folks?
Hey there.
John and Dave are here, or Francis. What the heck does that say? Chainsaw Gremp
Yes, from the movie Summer School.
from the movie Summer School. Okay, very
Yes.
good, very good, very good. And
I was I was I was Mr. Shoop a couple weeks ago, and so last
okay,
week I forgot to put a new character up there. So
you didn't want to be, you didn't feel like being somebody else next week.
right. I wanted to be me. Yes.
Well, I think if you want, if in the spirit of this week, you should be Jethro.
Okay.
There you go. And
I
we
thought you were
also have Tim Ward and John Messenbrink with us, and this dashing young man in the Golden Girls T-shirt
stay golden, baby. Stay
is
golden.
Patrick S., who is our guest speaker tonight from manufacturers rep in Minneapolis, Mondale and Associates. And Patrick will be giving you a presentation a little bit on the beauties and the theory and the reality and the practicality of water treatment for your boiler system. So that'll be coming up in about 20 minutes or so. Just want to say how you doing. Thanks guys for being here. We do appreciate it. We got about 78 of you on the line. I think we had 230 sign up. So I'm sure more and more of you will be pouring in as the next few minutes go by. So let's get this show on the road here. It's 7 o'clock. And where this is, of course, TACO After Dark Summer School. This is episode 3. It says episode 1 there, but we're talking about episode 3. And we're getting into our whole house system. The first 2 episodes, all right, the first 2 episodes, welcome to part 3. And if you note the t-shirt, Clamp It Oil, okay, Clamp It Oil Company, now you get the idea of what the theme of tonight is. Like, first week we had Pulp Fiction, last week we had Back to the Future. This week it's going to be one of the 2 or 3 greatest sitcoms of all time, in my humble opinion, the Beverly Hillbillies. And no, it's not just because of Ellie Mae. This was a very well done show. Anyway, but part 3, so far in this presentation, we spent the first week going over the whole house heat loss. And then we kind of crowdsourced part 2, one of the topics for part 2. Now, you guys told us in part 2, you wanted to hear about water treatment. Well, Patrick was on vacation last week, so we had to postpone water treatment to this week. And last week we also did a presentation on radiant system design. So last week specifically, again for our summer session, it's all about having some fun. It's about being, a nice relaxed summertime vibe, etc. And just do our crowdsourced topics, and we're going to do a little bit we'll ask you a little bit later, what do you want for next week for our crowdsourced topic after we finish up this session. So again, we're trying to just keep this relaxed, keep it fun, and have a good time. Real quick, let's go over just navigating the control panel. Just for those of you who are first timers, you should see that little arrow in the upper right hand portion of your screen, okay, that orange arrow. Just click on that orange arrow and expand the control panel. All right, you click on it to go to the right, you click on it to make it go narrower. When you expand that, you'll see all different kinds of things that you can do. The most important one is right here down at the bottom. This is where you're going to ask your questions. A lot of you guys, again, if you've been here before, you know how to do this. But if you haven't, click on that and just type in a hi, hello, how are you? We got a few already coming in from some different folks on just saying hello, hi, how are you? Got from Jason Mangos, how you doing, Jason? Chris Warner, Mr. Trotter is there, Ken Watson. Oh boy, this is just piling up. Great, excellent, good guys, terrific, 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 terrific. All righty, so everybody knows how to do that. That's fantastic. Now, last week we went over we went over the entire heat load. Okay, we had 20,000 plus on the first floor, 10,000 plus in the basement. This 2,300 square foot home in Norwich, Connecticut had a heat loss of only 30,577 or thereabouts. Now, we had a contest for people to put in their best guesses, and we're going to pick a winner for that a little bit later on, along with the trivia question from last week for some fabulous TACO prizes. That'll be going, that will be going over in a little bit. We did a baseboard overview. We did a radiant design tutorial last week. So we were pretty busy last week. This week, we're going to go over our zoning and our heating layout. We're going to talk about splitting this thing up. We're going to talk about some of the finer points of baseboard. We're going to talk a little bit about panel radiators. We're going to talk a little bit about kick space heaters and trying, figuring out how to interpret what those charts tell us so we can pick the best solutions for this job. So again, we're going to look over some baseboard specifics as we see here and look at the panel radiators. Again, I don't know how many panel radiators you guys put in out there. Let us know if you guys put in a lot of them. Just let us know. I know they're kind of cool. They're ubiquitous in Europe because it's just an easier way to install heating systems over there. They don't do series loops. But it's something that you guys do a lot of. It's an interesting way to heat a house, and you do your supply and return, and you've got a lot of different manufacturers available here. So we're going to talk a little bit about those as well. All righty, and then Patrick, our guest instructor, is going to get into the finer points of boiler water treatment, why you should do it, what you should look for, what kind of things untreated water can do to a system. Patrick's got some pictures that'll scare the heck out of you. So we'll be going over all that stuff. So with all the preliminaries aside, let's get this show on the road, shall we? And I always found it interesting that Ellie Mae could whoop anybody in the family, especially Jethro. But then again, I think she had a big head start in brains on Jethro. No offense, Dave.
Yeah, just a small bit. Yeah.
Just a small bit. There you go.
All the women are smarter than us anyway. So.
Well, there's that. Yes, there is that.
Yeah, we all know that. Yes.
Yep, it's the things you learn.
We don't think it all the time, but.
And we sure as heck don't say it. Yeah. Alrighty, folks, let's get started on our zoning. So we're going to zone this thing up. Now, just looking at this, how many zones do you see? All right, just type something in for me. How many zones, looking at this thing, do you see? All right. I'm wondering. On this first, we got David Leary. Daniel says 3. Logan says 4. Terry says, hi, hello, how are you? Yes, we got 7 zones. I got 4 zones. Okay, this is pretty good. 2 or 4. All right, I guess it would depend on how you're heating this thing up. If you were heating it with radiant floor heating, you know what I would see? If this was radiant floor heating, I would look at this and I'd see 1, 2, 3, 4, 5, 6. That's how I'd see it. And zone 2 is this area here. That's kind of how I would look at it in radiant. Now, would you zone these 2 bathrooms together or separately? Take your pick. It's either 6 or 7, either one way or the other, if it was radiant. If it was series loop fin tube baseboard, all right, which was one of the things we're going to go through today. If it's series loop fin tube baseboard, I'm looking at 2. All right. Yeah, you'd probably put all those bedrooms together in the bathrooms just because it's that wing of the house, and that's kind of how you do series loops. All right. And then the family room, kitchen, dining room, living room would also be a single zone. You can see a case for making it too. But when we start looking at loads here, people, these loads are itty bitty. There's just no 2 ways around it. So I'm looking at 2 zones here personally. But again, if you want to do 4 zones, you can certainly do that as well.
Yeah, I would do 3 to 4 if it was baseboard. I mean, separate out that master bedroom suite, so to speak. And I look at it from the standpoint of, the other 2 bedrooms, they're kids, right? What's happening to them in a few years?
They're going to be gone.
They're leaving. Yeah, they'll be back.
They always come back.
Yeah, they always come back. So, but at least while they're gone, turn that stuff down. And even if it is baseboard, and if you wanted to even zone it like a radiant house, there's no reason why you also couldn't use a radiant manifold for this.
Right.
To install it, because you start thinking, it's going to get really complicated. Well, if we're looking at 4 feet of baseboard or 10 feet of baseboard on a zone, use all that 1/2 inch PEX that you had left over on some project that you had used before, put a manifold on the wall and put actuators on it. And maybe not even put actuators on. You can still make it all one zone and then tell the homeowners, hey, if we want to zone it, all we have to do is add an actuator and a thermostat to it. So there is no such thing when it comes to normal in number of zones in the house.
And in life in general, as we've learned. Yeah. Now you make a really good point there, Dave. I mean, I could see if we were to, if we were to change this around and do a radiant manifold and use up our half-inch PEX, okay, now I'm starting to see, okay, now we can certainly zone this a lot more aggressively, even if it is fin 2 baseboard. Now with the garage, obviously it'd be in a slab, you'd want to do radiant out there. And you'd obviously zone that separately if you were doing the garage. Absolutely do it separately. There's no reason to do it the same way. You know, and there's no, you wouldn't want to put baseboard. Maybe you'd put a unit heater out there if you didn't want to do radiant. I've seen people do that. It depends on what you're going to use the garage for. Now, Patrick, out in Minnesota, the garage is just an extra room, right? I mean, people.
Oh, absolutely, absolutely.
Yeah, man.
You keep the boat. You have 3 bays. You have two for the his and her cars, and that third base for the boat and the snowmobiles. And then there's always a section of that garage that's set up as a man cave. So yeah, of course you're going to heat it.
Yeah.
Alrighty, so we're gonna proceed as though we're 2 zones, but again, we have so many variables here as well. And I like that point about the kids moving out. Yeah, keep those other two bedrooms separate. Absolutely.
Yeah,
Now,
and you know, I think also it's a conversation to have with the customers, because you go and ask them how many zones do they want, and they're not going to know. They're not going to know the answer. So the other thing to consider when talking to homeowners about zoning out a structure, or zoning out a place, is, you know, why do you want more zones today than we did, say, 40 years ago? 40 years ago, it was 1, call it a day.
Mhm.
All right. Now we're seeing 2, 3, 4, maybe as the norm. It's because people want more control over their heating system. So they don't know anything that's going on downstairs. Their only interface to the heating system is the thermostat on the wall. So if they want to put in 5 zones, great. If they want to put in 1 zone, okay. But when you have that 5 zones, if you make it 1, you kind of compromise a little bit, you know, where the thermostat gets placed too.
Right.
You know, so you get more control, you get better comfort out of it, and obviously with modulation going on and everything, modulate the world. Now you can start matching and getting better with your system too.
Yeah, I think with the technology available today, it's very easy to offer this to your customer and give them the explanation as to why it's to their benefit. You know, to get aggressive with your zoning. Absolutely, just to understand, especially on a house this small, more zones we have, they're micro zones. We are going to be more and more concerned about that short cycling that we've been talking about. Buffer tank on that boiler, which is something we're going to talk about next week. Buffer tank on the boiler is going to be very, very critical. You've got so many things. The more zones you have, the more likely we are to have some short cycling issues. So those all have to be taken into consideration. Oh, thank you. My wife just brought me another Poland Spring. She's the best. Thank you, dear.
You're welcome.
She's good. I'm punching way out of my weight class here. I'm telling you, she's you've met her, Dave. By every measurable metric there is, she's way out of my league.
And she knows it too.
And she knows it, and I know it too. So it's she's a rescuer. She must be. All righty, let's talk about some FinTube. Again, we've talked about FinTube before, but I just want to try a slightly different brand. BTU per hour right here. It's based on average water temperature. That's the important part. Average water temperature. We tend to look at baseboard and we say, well, it's 500 BTUs, 800 at 180 degree water, or 550 BTUs at 180 degree water, or whatever it is. And we think that's the supply water temperature, and that's kind of our go-to number. But what we're talking about here is average water temperature. So if I were to have 180 degree average water temperature, that means my boiler supply water has to be 190 degrees, and I'm designing to a 20 degree delta T, obviously. So 190 going out, 170 coming back, that's an average of 180. Now, a lot of cases we don't do that. We design to a 180 degree supply water temperature with a normal common boiler system, 20 degree delta T. So it's 180 going out, 160 coming back. Now that becomes an average of 170. So instead of using this column, we have to look at this column right here at 4 gallons a minute and 1 gallon a minute. At 4 gallons a minute flow rate, we get 510 BTUs per linear foot. At 1 gallon a minute, we get 480 BTUs per linear foot. Well, which one do you use? As we talked about last week, every one of these baseboard, charts, output charts, will have the following disclaimers, and you can see it down there at the bottom where it says the use of IBR approved ratings at 4 gallons a minute is recommended. Let me move this here. Is recommended for all normal loop systems where the water flow rate is equal to 4 gallons a minute. I think that qualifies as a well duh statement. This other one's another well duh. When the flow is unknown, the IBR approved ratings of 1 gallon per minute must be used. So we don't know that the flow rate's going to be 4. So we don't know that. So we're going to have to use the 480 number, right? We're going to have to use 480 BTUs per linear foot in this example. Now, what's the difference? If I goose that flow rate 4 times, all right? I mean, I increase it 4 times. I get, in this example, 30 more BTUs. That's about 6%, 5 to 6%. So this tale that, oh, well, if you reduce the flow rate, your output goes way, way down. No, it doesn't really. It goes down a little bit. And it's a very, very small amount. It's about 5 to 6%. So with a 400% or 300% change in flow, we get about a 5 or 6% change in output. So just make sure you understand that when people talk about delta T pumping and changing the flow rates. All right, it doesn't eliminate your output. All right, let's continue, and now let's look at zone number 1. Now I'm going to include all of these rooms here in zone number 1. Our family room. All right, our family room had a total load of just over 2,900 BTUs per hour. If we're going to use that 480 BTU per foot number, it's simple math. We come up with about 6 feet. All right, now this is a weird room because this is a sliding glass door right here. So we can't really put it under the window. We're going to have to either put it here or here. Now we're going to choose right there for that 6-foot piece of baseboard just because it seems to make sense. All right. Now, again, there's a lot of other ways we can do this. We could split it up and put 3 and 3, 1 on each side. That's fine. The kitchen is going to be interesting. The kitchen also has about a 2,900 BTU heat load. So that's going to be another 6-footer. But the question here is where are we going to put it? There's no real simple place to put it. I don't know. You guys tell me, if looking at the kitchen, if you wanted to put in 6 feet of baseboard or some kind of a radiator, where would you put it? I'm not entirely sure. What do you guys think? Type in your answers. We're going to look at a kick space heater in here, Mark. Absolutely. And that's going to be a real good alternative here. But if you wanted to use a piece of baseboard or a radiator, there's really no place to put it other than by the stairs, by the stairwells, right here, by the stairwell wall right there. So if we were going to do that, that's really kind of our only choice for a 6-footer, making sure we stay out of the way of the door, etc. All right. So that's really about the only spot you can put it, which again makes a kick space heater a viable alternative. Now, which one? All right. What are we going to do? There's a lot of different kick space heaters out there of different types of output. I'm looking at a Beacon Morris here, not to endorse it, just this is the output chart that I had. And you see the different models at different flow rates, all right? Different models at different flow rates. So 1 gallon a minute, 2 gallons a minute, 3 gallons a minute, they're all there, and at different water temperatures, okay? Now we're looking at 180-degree water temperature. Now in this case, they're talking about entering water temperature right there. So we can use 180. And we look at the 1 gallon a minute flow rate, and we see the model 42 has an output of 4,278 BTUs. The 84 is 8,460, and the model 120 is 11,585. Well, we're not going to bother with either of those. Why would we? All right. We're going to look at the model 42 at 4,278. That's well in excess of our 2,900 BTU output. So let's take a look down at the bottom. I always like looking at the fine print under these things as they tell you a lot. So the first line here is it's based on a 65-degree entering air temperature, just like baseboard output is, with the fan at the high speed, including the heating effect factor. Okay, that's the energy it takes to warm everything up. What they don't tell, what isn't listed in the chart, but is listed here, is your rating is reduced by 15% if that fan is at low speed. Now, in this case, pretty clear we're going to want to put this at low speed. So 4278 times 0.85, that's 15% less. That's about 3,600 BTUs. We're fine. Okay, we got more than enough BTUs in that kitchen with this particular kick space heater. So that would work, and that would be an interesting solution here. We could also look at radiant floor heating using the information we learned last week. We could look at a panel radiator, which is something we're going to look at now. Now, panel radiators, this comes from Runtal, and everybody has their own different outputs. Now, these are from Runtal, and you can see you have the 6-inch high radiator, the 9-inch high radiator, and the 12-inch high radiator. And at 180 degree water, again, entering water temperature, 180 degrees, they're listed at 600 BTUs per foot, 770 BTUs per foot, or 930 BTUs per foot. So now it just depends on how, do you want a taller, shorter radiator or a lower, longer radiator? All right, we're looking at 2,900 BTUs. If I wanted to choose the 6-inch high radiator, I'd look down here and say, well, a 5-footer is 3,000 BTUs. Oh, Glorioski, Captain Kilowatt, that looks just fine by me. Well, what if I didn't want that long of, I wanted a taller and shorter radiator? Well, then I can go to the 9-inch, all right, and I'm looking at a 4-footer at 3,080 BTUs. That looks fine. And if I wanted to go taller still, go to a 12-inch 12-inch radiator. Well, now I really can play some games here. 3.5-footer or a 3-footer. 3-footer, I'm going to be a couple hundred BTUs short, but if there's a person in that room, they're giving off 400 BTUs anyway, so it's kind of a jump ball. So you could either go with either one, depending upon what you want to do and what you want to look at. All righty. So I'm gonna check and see, how are we doing for questions there, Dave? Anything looking interesting here?
No, just lots of comments on what you were talking about before, so we're all good on the question wise. Yep.
All right, very good, very good. Okay, so that's panel radiators and with Runtal in specific, but all of them do it. They'll have different multipliers for different water temperatures. So say I wanted to run 140 degrees instead of 180 degrees, Runtal will give you a multiplier. You just multiply that output by 0.58, okay, for 140 degree supply water temperature. So it would be, 3,000 BTUs times 0.58. So it'd be about a little over 2,000 BTUs, okay, about 60% of that. So or a little under 2,000 BTUs. So as with any radiator, like we've talked about with baseboard as well, so with any radiator, when the water temperature goes down, the output per foot goes down. You're going to need a bigger radiator. All right, nothing wrong with that. You're just going to need a bigger radiator. So you can certainly size your baseboard into baseboard, you can size your panel radiators, you can size your kick space heaters at different water temperatures. All right, going back to the kick space heater though, real quick, I want to show you this. Right here, you see these those asterisks. Okay, the asterisks tell us that at lower water temperatures, there's the blower operates at water temperatures above 140 degrees with a standard self-contained aquastat. If you want to run lower water temperatures, you have to get a low temperature aquastat included with it when you buy it. Otherwise, the reason they put that aquastat on there so it's not blowing cold air. Okay, it's only if the water temperature drops below 140 degrees, things not going to come on, because why blow cold air? Now you can certainly size it for, in this case, 130, 120, or 110 degree water. You just got to know that that's what you're doing, and you'll need a different aquastat. All righty, very good. All righty, let's continue with our dining room. All right, the dining room was 2,000. That's about 4.5 feet based on 480 BTUs per foot. All right, and the living room was 2,800. Again, we're looking at another 6 feet there. The entry was pretty small, only 1,400 BTUs, so we're looking at 3 feet. And if we were going to do a series loop, we would just connect all our stuff like so, and bring it back down to the boiler. And there's your series loop. If we wanted to do 2 zones, all right, there's zone 1 and there's zone 2. more or less. You'd probably want your pipe a little straighter than that, but you get the idea.
Oh, it's under the floor. No one's going to see it.
Yeah, nah, you're not going to see it. Who cares, right? But anyway, and again, if there were panel radiators and you wanted to do a home run to each radiator, you can certainly do that too. And there's a lot to be said for that. All right. Very good. Very good. All right. Zone 2. Now we got our bedrooms. And again, bedroom 1, we did this last week. That was about 2,800. I'm sorry, about 2,800 BTUs. We were talking about 6 foot there. We had a 4-footer in that bathroom. Bathroom number 2 had like 75 BTUs worth of heat load. So I don't know what you're doing. You put a couple feet in there behind the water closet, maybe. This case, radiant makes a heck of a lot of sense. I don't know if you'd spring for a kick space heater for a bathroom that's got 74 BTUs worth of heat load, or maybe you just do a heat lamp. You know, those kinds of things work just fine. It's all indoors. It's all interior walls. There's no exterior walls. So there's really no heat loss, but you just don't want to risk a really cold bathroom when you're wet and naked. So I don't know. You guys tell me what you think you would do in that application. All right, what you would do with that bathroom number 2. Let me know what you think. Again, there's so many different options, but there's a lot of ways to do it. And why does bathroom baseboard always rust away? Because boys can't aim, Daniel. That's why. They should sell fin tube for bathrooms that's already pre-rusted and just save everybody a whole lot of time. I think that might be the best way to go there. Yeah, the heat lamp sounds like electric radiant. Sure, I think electric radiant's a good idea here too. Absolutely. You know, you don't want it cold, right? You don't want it cold, but you only got a 75 BTU load. So what do you do? You know, so I like that idea of electric radiant floor. I think it's a good idea. All right, bedroom 3, let's continue now. Bedroom 3, we had about a 2,600 BTU load. All right, and that came out to about 5.5 feet at 400 BTUs. And then bedroom 3, this was the one that was interesting when we did this back at our factory. Bedroom 3 was, you know, it looks like a 10 by 10 bedroom or 13 by 10 with the closet. It only had a 1,679 BTU load. This is 3.5 feet of baseboard. When we did this class at the factory, I remember a guy saying, there's no way. I cannot put 3.5 feet of baseboard in there. I won't do it. He says, why not? It won't work. Said, but you just did the heat loss, right? Yes. Do you believe the numbers? Yes. So the numbers say it's less than 1,700 BTUs. Yes. Then you can put in 3.5 feet of baseboard. No. He was going to put in 5 or 6 feet come hell or high water. I said, your house, do what you want. It really doesn't matter. You know, at that point, you're over radiating, but okay, that's fine by me. So anyway, yeah, and there's different. I've got a couple comments here about you know, about a hydronic towel bar with a Venturi T. There's a good idea. You know, towel warming radiator. You can certainly do that. You can do that actually do that in both bathrooms.
Both
Might not be a bad idea, you know.
Yeah.
Venturi, I think that would be a really good idea, actually.
You
John,
just need to explain one thing to the homeowners. You're not going to get warm towels in the summer.
Right.
They get upset with that. They get upset with that. I used to design and install towel bars in a lot of homes back in the day, and the homeowners would be upset about it because they didn't have a warm, unless they had to put a timer on it or turn the heat up in the bathroom to make it work. So it's always a challenge to make a towel bar run in the summer.
Yep. Absolutely. Yeah, because it's not doing anything. It's not going to be running it. That you just hang the towel on. But in the summer, do you really need the summer? I like cool towels, but that's just me.
So, but hey, they see this thing on the wall and they want my towel's got to be warm.
That's right. Well, that's when you put in floor heating, and then people, you know, say warm, happy floors. People say, well, why isn't my floor warm? Well, it's the room. We had this discussion last week. If the room's comfortable and the floor is 75 degrees, that floor is not going to feel warm. It's going to feel 75 degrees and the room's going to be perfectly comfortable. If you want the floor to be warmer, what did we say last week? What's the easiest way to make a radiant floor heating floor feel warmer?
You asking me or the crew?
I'm asking the crew. What's the easiest way to increase the surface temperature of a radiant floor heating system? Open a window or turn up the thermostat. There you go. That's it. Good. You guys remember. Very, very good. Yep. Okay. Now, again, our zones, zone 1 was 12,116 BTUs. If we were to figure out the flow rate just for that zone, all right, 12,116 divided by 20 times 500 or 10,000, which is the universal hydronics formula, that's going to give us 1.2 gallons per minute. All right, that's not a lot of flow rate. It's not a lot of flow rate. Zone 2 was only 8,200 BTUs. All right, that's 0.83 gallons per minute. We're talking 2 gallons per minute for that entire first floor. Now, remember we talked about flow rates and things. If we were to take a look at this chart, this is for factors determining ratings at flow rates other than the standard. All right, so 1 gallon a minute, we had 480 BTUs. At 4 gallons a minute, we have 510. What would we have in terms of output at 2 gallons a minute? Well, you'd simply multiply, per foot of baseboard. If we were to do this real quick, let me break out my calculator. So 480 times 1.028, which is the factor for 2 gallons a minute, we're up at about, okay, we picked up 13 BTUs. We're about 493.5 BTUs. Okay, we're getting a little bit more output here. All right. Someone had mentioned, are we worried about the water temperature at the end of the baseboard run? Well, only on the coldest day of the year. Yeah, when we're going to be approaching that 20-degree delta T. In something this small, in a zone this small, because we're not going to find a circulator that's going to be too small for this, we really aren't going to be too terribly worried about that, as we'll see. But in this case, I'm already boosting the output per foot of baseboard because now I know the flow rate's going to be about 2 gallons a minute if this was all one zone. Okay, if they were separate zones, well, I'm going to have to work on 1 gallon a minute for each zone. All right, that's just kind of how the way it's going to be. And if I go 1.2 gallons a minute, that's somewhere in between 1 and 1.5. I get a handful of BTUs extra output. It's not a lot. So there's our zone totals. And before I turn it over to Patrick, I want to get our Takeo TV trivia question of the night out there. So what you're going to do is type in your answer once you know it, and it is Beverly Hillbillies focused here. And again, we're going to pick all the right answers. We're going to put them into a hopper, and we're going to pick a winner next week for this week, and you'll get a beautiful prize package courtesy of Takeo. I think it's like a $1 million gift certificate or something like that, Dave. I'm not sure.
Oh, exactly. Yeah, it's a scratch off for $1 million.
There you go. It's a lottery ticket. You may get $1 million. All right. So we all know the song.
I got some fun stuff to give away. Yes, I got a whole pile of things that was sent to me from the factory. So I got a plethora of stuff to give away.
There we go. There we go. I think we're getting some cool stuff too. I just got that email today too that we can throw in there.
Yep.
So the Takeo trivia question night. Everybody knows the song, right? You can imagine that song in your head right now, can't you? Right? You can imagine that song. The first thing you know, old Jed's a millionaire. The kinfolk said, Jed, move away from there. They said California is the place you got to be, so they loaded up the truck and they moved to Beverly Hills. That is, swimming pools, movie stars. Then they do the breakdown. Here's the trivia question. It's a two-parter. In what Beverly Hills bank was the Clampett fortune deposited? In what Beverly Hills bank was the Clampett fortune deposited? What was the name of the bank, basically? And part 2, what was the name of the bank president? He's in fact pictured here. What was the name of the bank president, and of what bank was he president of? All right, that's all we want to know. What's the name of the bank? What's the name of the bank president? That's our Takeo TV trivia question of the night on the greatest sitcom of all time, the Beverly Hillbillies. So let's get back to work. And as we all know, that's the thing about possum innards. They're just as good the second day. And speaking of possum innards, we're going to send it out to the Midwest, and we're going to talk boiler treatment with the man, the myth, the legend, the one and only Patrick. My last name is not an initial, S. How are you, Patrick?
Excellent, John. Thank you very much.
There's my dog barking. I don't know why my dog is barking. He must not like you, Patrick.
He likes me.
He loves you. He knows it's you. He knows it's you. All righty. So I have changed you to the presenter, and you are ready to rock.
All right. So everybody see my presentation here, John? See it all right?
Yep, you're up.
We
It's a
got it.
good looking presentation too, I gotta say.
Well, you know, I had a little help. Yeah, we'll go back here. There we go. All right. So, John, thank you very much for the opportunity. Everybody that's attending the training, thank you for your time. Hopefully, we can cover a topic that is very near and dear to my heart. And I do think it's one of the probably the biggest underlooked issues in hydronics today. And I think people are starting to recognize that and realize it. So, fortunately for us, we've got some interest in it. I work for a company called Mondale and Associates. We're a manufacturer's rep agency. We are a TACO rep up in Minnesota, North and South Dakota, and Western Wisconsin. And we also represent a product called Fernox. It's one of the many options that are available. So you know, for me, I think it's one of the easier products to work with. Obviously, I'm biased because I sell it, but at the same time, it has a lot of things that other chemicals and products can't offer. Very much like TACO pumps. You know, how many pumps out there have a bio barrier in it today to protect the ECM pump from black iron oxide water? It's an exclusive ability that the product has, and that's one of the things that I like about Fernox is they do offer some things. But we're going to try and keep this generic, and we'll run through some things. If you do have questions, please ask, and John will certainly prompt me to those, and we can address them. And we'll also have some time at the end of the presentation to address some of those questions as well. So some of the benefits of water treatment is, you know, to improve and maintain system efficiency, prevent system breakdown, reduce fuel costs, minimize environmental impact, and reduce callbacks. And I always kind of run on this slide because obviously there's a lot of different contractors out there that have a lot of different opinions, a lot of different business practices. And you know, some of this stuff may or may not fit you. So some people might look at water quality and say, it doesn't matter. It's not a big deal to me. It doesn't affect me. You know, you look at improve and maintain system efficiency. I'm not paying the bill. It doesn't matter to me. Breakdowns, I don't do service work. I let other people deal with that stuff. I just put them in. Reduce fuel costs. Again, I'm not paying the bill. It's not my problem. I just put the system in, get paid, and I move on. Minimize environmental impact. Some people think it's a pink unicorn. You know, whatever. It's your call. And then reduce callbacks. I don't do callbacks. I turn my phone off at 4 o'clock. I'm at happy hour. I don't deal with that stuff. You know, there's different practices for different people, and I think, you know, some people may fit that, some people may not. But the one at the very bottom here, complying with manufacturers, you know, recommended and requirements on water quality, I think is a big deal. And no matter who you are, no matter what type of business you may run, how you run your business, whether you do service or not, you need to make sure that the hydronic systems you're installing are complying with the manufacturer's recommendations and requirements on water quality. To my knowledge, pretty much every boiler manufacturer out there has a specific range of 6.5 to 8.5 pH. That's where they want the water to be. And if you're not within that range, they can easily void the warranty. I think more and more now in today's world, we're starting to get more familiar with the term called, you know, I guess it comes down to looking at the product, and they want to basically check it out before they warranty it. You know, it's, you know, credit upon evaluation is the term I'm looking for. And there's a lot of manufacturers that are utilizing that term, and rightfully so. As you can see on the slide, if you've got black water running through that system, that is not what the boilers are designed to operate with today. That's not what TACO pumps are designed to run with today, or any other pumps that are out there for that matter. So we'll talk about some of the solutions and some of the things we can do to address those systems. But more importantly, I want everybody to understand that, you know, we want our boiler systems to have pure, clean water in them, because black water is not what boiler water is supposed to look like. I remember back in the day, I was trained by some of the senior installers that, you know, well, why is this water black? Oh, that's just dead water. That's just water with the oxygen taken out of it. It just turns black. You know, those are all things I was told. Another one, another very false is, oh, that's a really good heat sink. It really carries heat well. All of those things are false. And for the most part, we know that today, probably more so because of condensing boilers. So what are the problems? The problems are obviously it's corrosion and limescale. Limescale is a buildup from hardness in the water, total dissolved solids in the water, and corrosion is basically due to increase or decrease of pH in the system. If I have higher than 7 pH, I'm running alkalinity, which can cause corrosion. If I'm lower than 7 pH scale, I'm acidic, and I'm also corroding my system. When you see black boiler water, that water didn't turn black on its own. That water turned black because it's carrying basically particles and pieces from the system which turn it black. Okay. With corrosion, all mixed metal systems will corrode. Ferrous metals corrode to form sludge. You'll get general and localized corrosion. Localized pitting corrosion can be very rapid at times. And generally, the byproduct of all of this corrosion is your black magnetite and red iron rust. Those are the typical byproducts of it. Or as TACO refers to it, BIO, black iron oxide. And that, remember now, that black iron oxide is also magnetic. So what is every ECM, every manufacturer, every ECM pump has one thing in common, and that is this: the rotor is a permanent magnet. And remember that black iron oxide, that black magnetite, red iron rust is magnetic, and that will actually attach to the magnetic rotor and cause that pump to fail. Fortunately, with TACO, we've got an opportunity to have a product that has a bio barrier in it to protect that from happening in systems that have not been treated. Today, we want to talk about preventing the whole scenario of black iron water altogether, and that comes down to water quality and water treatment. Okay, here you can see what happens with that the black iron oxide and the magnetite red iron rust is it attaches to the hottest point in a boiler system. So, you know, what is, I guess, just out of curiosity, does anybody know where is the hottest point in a boiler system? Yes, it's in fact in the heat exchanger. The hottest point in a boiler system is in fact in the heat exchanger. So that's going to attach to the hottest point. And the thing you need to understand when we're looking at it is, here's a great picture of a fire tube heat exchanger. Has anybody ever heard that a fire tube heat exchanger, the benefit of a fire tube heat exchanger is it doesn't require maintenance like the water tubes? Well, hopefully this picture can kind of show that that really isn't true. This fire tube heat exchanger, as you can see, this is basically a top-down version or view of that fire tube heat exchanger. You can see, where did all of the contaminants and buildup actually build? It built up at the top of the heat exchanger, right where that burner is located, the hottest point in the heat exchanger. Remember, all of those particles and pieces from the system are going to attach like a magnet to the hottest point in the boiler system. And what it will end up doing is preventing the heat from getting into the water on that heat exchanger, causing the welds, the seals, gaskets, all of those things to fail because they're overheating, because I can't absorb the heat because it's the heat exchanger is insulated from the water. So whether it's a fire tube or a water tube heat exchanger, water quality is critical. It's absolutely critical. Here you can see a picture, a cutout picture of a Giannoni heat exchanger. Here you can see where the burner meets that heat exchanger. You can see the black iron oxide just start to build up inside of it. It almost looks like a magnet. And what it's doing is it's preventing flow, but more importantly, it's preventing heat from getting into that water. It's basically insulating the heat exchanger from absorbing, or it's insulating the water from absorbing heat from the burner. So a lot of times people will look and they'll say, well, it's plugging up and it's slowing down water flow. My concern is more of it's preventing heat from getting in the water, because we all know if that heat from this heat exchanger, if the burner, if that heat can't get in the water, where is it going to go? It's going to go off the stack. Here you can see a picture of a warranted boiler that came in, and obviously it was due to a lack of maintenance. When they cut that system open, they could see that the heat exchanger was very plugged and it could absorb any of the heat. So it literally burnt a hole through the back of the boiler. Which is amazing. Now, the other thing is with condensing boilers that I always like to point out is, What are we venting these boilers in most cases? Almost always PVC. Remember, PVC has a heat limitation of about 150 degrees. And if I can't absorb the heat into the water because that heat exchanger started to plaque up because of that black water that's in there, you're going to start to get high exhaust temperatures. Anybody ever seen black, brown, or cracked or sagging PVC? Well, if you've seen that, there's a very good chance that your heat exchanger is plugged up with this because somebody didn't treat the water when they did the installation. So, those are some of the things that we're talking about today that we're trying to prevent. John talks about short cycling boilers. Well, you want to short cycle a boiler, start running this stuff through it, and you will definitely short cycle your boiler. It's just, and it's one of those things, again, credit upon evaluation. So no matter what type of contractor you are, no matter what type of business you run, you need to make sure you're complying with the manufacturer's recommendations and requirements on boiler water quality. So how can we prevent the corrosion from occurring? How can we go at a system and ensure that that system and that water isn't going to turn like this in 5 to 10 years? Well, fortunately, Fernox has a good product out there. There's some others out there as well, but there's products called protectors. And those products you can add to a boiler system, which will provide some long-term protection against corrosion and scale. They can help maintain efficiency of the boiler. They can help also maintain the water quality of that boiler so that it's within the manufacturer's requirements, just in case you ever do have a heat exchanger failure and you need to cover it under warranty. It helps prevent pumps and actuators from sticking and plugging up. It helps reduce boiler noise. It can also reduce some of the maintenance costs. So remember though, when we're looking at protectors, we want to make sure that the protectors we're using can actually treat all mixed metal systems, including aluminum, because let's be honest, there's some aluminum heat exchangers out there that we need to make sure that our protectors have the ability to work with nicely. Aluminum can be a pretty finicky metal, and you got to be careful with it, especially in boiler systems. The other thing is, are the protectors you're using, are they non-toxic? Are they non-foaming? I mean, those are other things you want to look at. If you're running it down the drain, can it be ran down the drain and things like that? Another very, very critical part of protectors, in my opinion, is what is the final pH of that protector? There's a lot of protectors on the market, and my suggestion is take a look, if you're using a protector, take a look at the instructions and ensure that the pH level of that product is actually within range of the boiler recommendation and requirement. Okay. The benefit of the product that we handle, of the Fernox, is it's always at a 7, 7.5. The other benefit of that product that you need to be aware of is when you're adding products, some products out there require that you add more inhibitor, or you may have to add a neutralizer to reduce that because they don't automatically go to 7 like the Fernox does. The product that we represent, if the pH is low, it brings it up to 7. If the pH is high, it brings it down to 7, which is very unique, and in my opinion, the easiest way to treat a system. It makes treating boiler systems very simple, which is probably the #1 reason I like it. I've always said, if you have a good product and it works well, okay, and it's easy to use, contractors will do it. I'll never forget, I went to a training and I learned how to check pH on boiler because I wanted to be the best service tech ever. And I learned how to test for pH, and I found a boiler in Chanhassen, Minnesota, and I tested that system, and I found out that my pH was low. I was running acidic. And at that point, I had no idea what to do to treat it. So I called about 5 or 6 different distributors in the Twin Cities market, and I got a hold of an older gentleman who said, oh yeah, you need to come in, you need to add an inhibitor to raise that pH. Ah, perfect. So I race over to the cities and I grab the pH, and he's got a container of neutralizer there for me. And I said, well, what's this all about? What do I need that for? He said, oh, you'll overdose it. So you'll have to go back and basically put the neutralizer in and make sure that you're at that 7 level that you're trying to get at. So basically I took a service call and I turned it into a 3-day process. I went there, I treated the system, I went back, I tested the system, put the neutralizer in, got it back down to 7. I went back the 3rd day to check and make sure everything was okay. And I can honestly tell you from my career and my experience, that was the last boiler I tested up until I found the Fernox product. Because in all honesty, My business practice didn't have time to look at that stuff. I had way too many other things to do that were way too more important than to take a service call and turn it into a 3-day ordeal and then explain it to the homeowner. It's one of the benefits of the product we represent. In my opinion, it simplifies that process very much by being able to not only lower the pH, but always also raise the pH and bring it into that 7.5 range, and not overdosing. I don't have to worry about overdosing with that product either. So to me, it makes water treatment pretty simple. Okay. So number one, we want to identify the product. If there's excessive buildup of sludge in a system, that can lead to premature component failure, and we need to address the problem. So if I have a dirty, plugged up system that I'm going to replace or look at and change, I want to clean that out. Fernox has a cleaner. It used to be F5. It's now F3. They changed the number, but it's an excellent cleaner. There are other cleaners on the market you can look at and use. Make sure you read the instructions of how those products are supposed to be introduced and how long they can actually be in the system. Product we represent, you don't want it in there for more than 7 days. I normally tell people 5 days because everybody stretches a limit, but the reality is you want it in there for 2 to 7 days. So make sure when you're using a cleaner on a system, know the fine print of how to address it, how to install it, and then how long can it be in. And then obviously, unless stated otherwise by the manufacturer, any cleaner we would always want to remove. If you ever install a cleaner on a system and it doesn't need to be removed, you would definitely want some means of filtration, be it magnetic, be it a strainer, but you're going to want something in that system that can remove the dirt and grime that the cleaner is removing from the system. So just keep that in mind. There's some products out there that are saying, oh, you just put it in and leave it. You don't have to worry about it. Well, there's a reason there's a rinse cycle on your dishwasher and clothes washer. You don't want the dirty stuff running around with your clean stuff. So if you do have a cleaner that you can put into the system and leave in there, it's not too acidic, just remember you're going to want some means of removing the dirt and sludge that the cleaner is taking care of. Showing what a protector can do. I like this picture because it helps show what protectors do. I actually have 2 jars here that I carry around with me, are very near and dear to me, but these are 2 samples. This one is treated, this one obviously is not. These are from 2011. This is water from the city of Eden Prairie. It's the same fittings in each one of these. The difference is this one has not been treated, this one is treated. So you can see the inhibitor package that we represent does a nice job, and in all honesty, should outlast the life of the boiler. The pictures displayed here do a nice job of showing that just after 8 weeks, that what can happen to untreated water in a hydronic system with hydronic components. And remember, all of those black particles, all of those pieces are going to end up attaching to the hottest point in the boiler. Okay. This is just showing a picture of my son, Jacob. This is actually at my house. I had a failure at my house. I put a glycol in my own house in 2009, and it would have been probably 2015, right around 5 years of installation. The inhibitor in that glycol died, and I didn't know anything about glycols at the time. Come to find out that a lot of glycols out there, inhibitors, need to be reconditioned and checked periodically because they will die and break down. Again, one of the benefits of the F1 inhibitor that my son, Jacob, is actually putting into our system is it should outlast the life of the boiler. It's been an excellent product. I will say when I changed my expansion tank out on my own home heating system, which is in-floor in the basement and the garage, I also put a Taco VT2218 in there. And I'll tell you what, that is a fantastic pump. It slowed down to meet the load. I had a more comfortable basement, and my garage was not overheating like it did with the previous pump I had on there. So it's been a nice addition. I really enjoy that pump. Picture of Jacob putting it in there. If you've noticed, he doesn't look really happy there. He wanted to help his dad, and I said, well, let me take your picture, and he was pretty reluctant to have his picture taken. I said, well, fine, you know, let me take your picture. You don't get to help me. So there he is, and shooting a can of protector in, and he was not real happy about it, but he took his picture. So a lot of people have seen that picture. I get a kick out of it now because I tell him he's famous, so he thinks that's funny. So when we're using cleaners for new systems or existing system installs, yes, you actually want to clean a new system, and if you're doing a change up, you would want to clean an old system before you put the new boiler in. You want to make sure that your cleaner is a universal system. that matches for aluminum and different metals that may be existing in the system. You want to make sure that your cleaner removes the flux and residue from insulation debris. You want to make sure that your cleaner is non-acidic and non-hazardous. And last but not least, again, you want to make sure it's compatible with all metals. So last thing you want to do to an aluminum heat exchanger boiler is put the wrong chemical in, because it will be devastating to that heat exchanger. Okay. These are two of my favorite slides. I love these slides. Great story behind these two slides. I was in St. Cloud, Minnesota, doing a boiler training. And anytime I do a boiler training, I always talk about water quality. I'm a firm believer that if we had been talking water quality long ago when condensing boilers came to market, there are some condensing boilers that would still be prevalent in the industry that got kind of dropped off. And I believe they got dropped off because people were having problems with them. And I think a lot of those problems were due to poor water quality. So I like to tell people with this slide, and the gentleman that I was telling this to, after I told him about cleaning water and treating water, he was kind of sitting there just very standoffish in the class. And I looked down at him and I said, well, you're not taking what I'm putting down here. So what's going on? What's running through your mind? And he said, I clean every system I've ever installed, and I've been doing this for 30 years. I said, well, that's fantastic. You know, what are you using to clean it? He said, I don't use anything. I use raw water. I run fresh water through that system, and when all that black crap comes out and I start getting fresh water out, boiler's cleaned. That's how I do it. That's what I've been doing for years. I said, well, that's fine. I guess I get that. That's how I used to do it before I learned a couple things, and that's what I'm trying to share here. So I appreciate the question, but let me ask you a question back. You said you've been doing this for 30 years. He said, yes, I have. I said, all right, you ever get that black water? You ever get that stuff on your hands, and you go home with it? No, basically, you can go to running water with soap and under running water, and you're scrubbing your hands, and do they come clean? And he looked at me and he laughed. He said, no, they don't come clean. I said, exactly. I said, but somehow, miraculously, just running raw water through those boiler pipes is cleaning all that stuff up without any soap, without any scrubbing, just raw water. You can't get it off my hands scrubbing with soap, but somehow just running through that pipe, it's cleaning it up. And he looked at me and he said, you got me. And I said, I'm not trying to get you. I'm just trying to point out that I used to think the same thing you did. I'm flushing and cleaning it out. I don't need a cleaner. But in reality, with a cleaner scrubbing my hands, I can't get it off my hands. So I would say today in 2020, it's probably a good practice when we're doing a replacement. We want to flush those systems out with a cleaner before we put the new one in, and then treat it so that we don't get the corrosion that was in the system, the previous system. The picture of the old car is one of my favorites. I like to use it to try and sell the fact of cleaning a system to the contractor and the homeowner. And I love to say, all right, I took my old car in and I'm going to trade that thing off and I'm going to sell it. I finally got my last $1 worth out of it. It's ready to trade it in. And I'm going to buy a new Cadillac and I'm going to drive that thing off the lot. And just as I sit in the car and I put the key in the ignition, the service manager comes around and I says, hold on, don't start it. Don't start it. It's not ready yet. Well, what do you mean? The check didn't clear? No. See, we have to take all the fluid out of your old car and put it in the new one, because the new one doesn't come with fluid. So all of the transmission fluid, the oil, the antifreeze, the brake fluid, power steering fluid, hell, even the windshield washer fluid. We got to take that all out of the old car and we got to put it in the new car. And I always ask people, once you realize that and hear that, would you buy the car? Now, out of all the years I've been training on this, typically I get 2 or 3 wise guys that'll say, how much for the car? I could change the fluid. But the reality is, when we go to change that old cast iron boiler up, and we go to put that brand new high efficient condensing boiler in with ECM circulators, the latest and the greatest, the best system out there, if we're not flushing that system out first, we're taking the old fluid from that system and putting it in that brand new one. And then we're asking the manufacturer to warranty it. Again, credit upon evaluation. There's a reason these terms are starting to come up. I don't know why anybody would expect this car to be warrantied with the fluid from that car. Okay, well, when we change a boiler out, if we don't flush and clean that system out, that's precisely what we're doing. We're taking the old fluid from the old system, we're putting in a new boiler, and we're expecting that thing to work at its optimum efficiency and be warrantied for 10, 12 years, whatever the warranty is now. Okay, so You know, feel free to use that with your homeowners when you're out there offering and talking about servicing and cleaning and treating water. To me, that's a really nice comparison I think most people can understand. Right? So how does it help efficiency? This is a slide I used to ditch, but I really like it now. One of the reasons I like it is it helped me understand, you know, how important cleaning a system is. So basically we did a study. A single family home in Boston, Massachusetts had a Vidaris GB142 boiler, aluminum heat exchanger installed in 2007. Okay? Had 10 cast iron radiators estimated from the 1920s, 2 flat panel radiators as well. They went through and they flushed that system out. They did a power flushing on it, put the cleaner in, flushed it all out. And after flushing it, we saw an increase of 15% efficiency. Now, initially I thought, well, 15% efficiency, big whoop, what's the big deal? But think about that for a minute. What do I gain when I change out an 80% cast iron boiler to a 95% condensing boiler? What am I gaining? I'm gaining 15%. How much does that cost? Okay, compared to just flushing a system out. Now, we all make a living changing out boilers and selling boilers, so I want people using this to sell boilers. So what I'm telling people is simply this. If I'm on a job and I'm doing a bid for a homeowner, the first thing I'm going to do is pull some water out of the old boiler, because I know the other 5 competitors that were in there did not do that. And I'm going to show the homeowner this, and I'm going to say the first thing is first, if I do this job, I need to flush and clean your system because it's absolutely filthy and it will not be within the new boiler's warranty specs. So I'm going to have to clean it up. The good news is if we go with a high efficient boiler, you in all honesty should see about a 30% increase of efficiency, because you're going to gain 15% by cleaning this. You're going to gain another 15% by going condensing with the high efficient boiler. Those are some real numbers that I would hope you would use to help grow your sales, and also make sure we're doing these systems right and doing the homeowners right. You know, I think it's something that we should be offering, and I know that if you are offering it, more than likely going to get that job, and you're not going to get it because you're the cheapest. And I think that's what every contractor out there is looking for. If they're not looking for it, they should be. Okay.
Hey, Patrick, Patrick, I just want to jump in real quick. We got a lot of questions in the queue here, but I want to let you finish up, and then we'll jump into those questions because you're on a roll and doing some great stuff. There's some really good questions. So guys, if you're hanging on for your questions, keep hanging on or keep typing them in. We will get to all of them, I promise you.
Fantastic. That's good to know, John. I didn't know if I had sleepers or what, and we do kind of have a lot to pack in, so I apologize if I'm going quick, but we can cover everything at the end, so thank you. This is just showing a U.S. water hardness map, and I love showing this map because all I hear about in specifically Chicago or anything around Lake Michigan is about how great their water is. Oh, it's wonderful, it's fabulous. Well, if you look at this map, I would beg to differ. You start to see that it's very hard, and understanding hard water, you know, it number one will not play nice with glycols. There's a lot of glycols out there that have a limitation of how hard the water can be that you mix with it. Fortunately for Fernox, the glycol we handle and carry handles up to 70 grain hardness, which is extremely hard. Okay, but the other thing is you know, we get with hard water, that hardness in the water can actually separate out from the water and start to plaque up and scale up heat exchangers, and it can do that pretty easily. And you know, one of the benefits of some of the inhibitors out there or treatments out there is they can actually buffer out the hardness. Again, one of the benefits that the product we represent can do. So, you know, understanding your map and where you're at, I always get a chuckle because, you know, people will say, well, you just deal with North and South Dakota and they got horrible water, but over here our water is great. Well, you know, I've yet to find a place that has perfect water, but, you know, I haven't been over on the East Coast yet, so maybe I need to get over there sometime, John, and check it out. It looks like the water's all right out there, but you start to look at the Midwest and some of these areas, and there's definitely, according to this map, looks like we've got some water hardness issues, things we need to look at. One of the byproducts of hard water is lime scale. Also understanding if you guys are doing on-demand water heaters, a lot of these on-demand water heaters out there have a limit of how hard the water can be. You may have to, in fact, put some type of a scale filter on there or a water softener to bring that hardness down to the level of the manufacturers. But one of the byproducts of hard water is lime scale and buildup. Okay, you know, it's calcium carbonate, deposits by heating hard water. It reduces boiler heat transfer, gives higher fuel bills, and can block some valves. All right. There are heat exchanger cleaners that are available to flush and clean the heat exchangers out. Just understand with different manufacturers, there are heat exchanger cleaners and then there are system cleaners. Don't mix them up. If it's a heat exchanger cleaner, it's for the heat exchanger and only the heat exchanger. If you start to put that cleaner out into the system, you can open up a tremendous can of worms and create a lot of leaks. So make sure that you understand the difference between a heat exchanger cleaner and a boiler system cleaner. And then also, I like to show this picture because there are actual external heat exchanger cleaners for the burner compartment. If you've ever tried to service a Giannone heat exchanger, you'll realize they can plug up with some nasty stuff, and it's nice to have a cleaner to help break that down. You should never clean a Giannone heat exchanger with any type of a metal brush or any type of a high acid corrosive cleaner, because if it's tripping the metal, it's actually damaging the heat exchanger, and that's the last thing you want to do to one of those heat exchangers. You want to use a nylon brush, typically your wife's credit card, and some type of I guess, an acidic cleaner, but an acidic cleaner that's not going to attack the metal. This is just showing another example of the fire tube heat exchangers. Yes, they actually plug up as well. Again, the heat exchanger that doesn't require any maintenance does plug up and does need to be cleaned periodically. And again, the external heat exchanger cleaners is what we use on the burner side for that. Glycol. I will tell you right now, one of the most important things I learned out of the product we handle, which is the Fernox, is glycol. I didn't know a lot about glycol. I thought they were all the same. That couldn't be further from the truth. The things you need to know about your glycol is, number one, is it aluminum safe? Number two, what is the pH level of your glycol at the solution you're requiring? And that's important. Why? Because most boilers have a pH of 6.5 to 8.5. Okay, there's a very, very common glycol that's used that has a pH of a 9 to a 9.5, and people are using it all over. So you need to start looking at that, because if you're using a glycol that's out of range on the boiler manufacturer you're working with, you could run into some problems. Another one is, how long does the inhibitor last? Are you going back and checking it? The glycol we represent has an inhibitor that should outlast the life of the boiler. Most others, it's right around a 5-year mark. So you got to get back and check it. If the inhibitor dies, you need to put inhibitor back in there, or it's going to become corrosive very fast. Okay. And then what are the inhibitors made of? Are they made of phosphates, nitrates, phosphorus bearing, nitrites? All of those things can actually promote bacterial growth in a low temp system. So you want to understand what you're using there. Another benefit the product we look at and represent, we don't have those things in there. We're just using that F1 as our inhibitor. Another good question is it a concentrate or is it a pre-mixed glycol? A lot of glycols out there that are pre-mixed, make sure we can check with your manufacturer or your rep agency that's repping that product. Is the mixture pure? Some of the manufacturers out there are saying, well, it's supposed to be a 55-45 mix, but sometimes it's 70-30, and it depends if it's settled out and whatnot. To me, I would go with a concentrate because I know what I'm getting, and all I have to do is do the math, and I think it's pretty simple to do that. Last but not least with glycols, and this is critical, follow the instructions. The devil is in the detail. You need to know your facts about glycol. The benefit of the glycol that I represent is, I always ask people, are you looking at the water quality? No. Are you going back and checking it and reconditioning your inhibitor? No. Are you using hard water in those systems? Well, no. Well, if you use my glycol, you're doing it right. If you're using other things, there's a good chance you're not doing it right. So know your product that you're using there. I think it's important. Last but not least, should you use a water test kit? I would say absolutely. Okay. Number one, it takes away the guesswork. You're curing the cause, not the symptoms. It's what professionals do. And last but not least, a service tech can confirm inhibitor concentrations, and then if there's possible contaminants in there. I used to, back when I was in the industry, in the field still working, I always kind of said, a boiler tune-up, there's nothing to do. You pull the burners out, you clean them, you clean the flame sensors, you turn it on, and that's about it. You maybe check your exhaust temperatures, check your efficiencies, but there wasn't a lot to do with it. I should have been testing water. I wasn't, but I should have been. I will tell you today that if a technician is testing the water, even if that test kit is $500, that test kit is going to pay for itself in the first week, because we all know majority of the systems out there need to have the water service. And if you start to implement that into your boiler services and your boiler tune-ups, think of the amount of revenue and the amount of work you can create by treating those systems. And in all honesty, if I pull up boiler water like this, do I really even need to test it? Okay, I think I can adequately look at that and say, yeah, it needs to be flushed and it needs to be cleaned, flushed, and then refilled with water and treated. So I think testing is something that should be done, especially if you're doing hydronic system and service work specifically. Okay, what do you want a water test to provide? To me, the big one that I need a water test to provide is an inhibitor test, pH, and hardness test. Those are the big three that I'm looking for. Copper and iron are nice. Chloride is nice as well because it can help us indicate what's actually going on in the system, what's the problem, so that I can learn how to address it. Some of the interpretations of those results are if I have copper in the system, high copper, or chloride in the system, the interpretation of that would be that flux residues are probably in the system from the installation. I would want to clean and flush that system out. High iron in the system could be one of two things. Either the water itself had high iron, which isn't a big deal if it's been treated, or there's iron content in there from the boiler piping itself. And those are something that, you know, if it was just iron content in the water and it had been treated, that water is still going to be pretty clean and clear. If there's a lot of iron content in it from corrosion, it's going to look more like this. So it's pretty easy to see that. pH level, obviously, less than 6 is bad. Greater than 8.5 is bad. 7 is neutral. It's a wonderful place to be with pH. That's the world we want to play in. Okay. If your pH is too low, you're going to want to flush that system out and then treat it with an inhibitor. If your pH is too high, you know, you're going to want to, if it's clean and clear, you're going to want to put a neutralizer in to bring that down. Or again, if it's dirty from corrosion, you're going to want to flush and clean that system out and then treat it. If there's hardness in the water, that's going to cause scaling of the boiler. Generally speaking, with hardness in the water, you're going to want to flush and descale and clean that system out, and then you're going to want to treat it with a treatment that addresses hardness. Again, one of the benefits of the Fernox product we represent. And then the other one is sometimes when people fill with soft water, you know, one of the problems with that is it can, number one, it can create foam from that, and then the other is, especially with aluminum, soft water doesn't play nice with aluminum and create a lot of problems really quick. If there's aluminum in it, you're going to want to flush that system out and then refill it with the mains water, the hard water from the house, not the soft water. And then last but not least, an inhibitor test. No matter what chemical you're using, there should be some type of a test to test that you have enough inhibitor in. With the product we represent, you do a little plastic vial, you fill it up to 10 milliliters, you put a drop in, it turns blue, you put 9 more drops, I call it the 10 and 10. You put 10 more, you basically get the 10 drops. If it stays blue, you know you have enough inhibitor in it. If it turns yellow, amber, or gold, you don't have enough. That's just the way we test our inhibitor package. There's others that are out there, but you should be testing it because if the inhibitor breaks down or there's not enough, you can become corrosive. So I appreciate everybody's attention to this and time on this. And I think, John, now we could probably open this up for questions. I think I ran about 35 minutes.
No word. That was fantastic, Patrick. I told you guys he was good. I told you. There's a boatload of questions here. Let's see. First one was just, do I need to use Fernox for antifreeze? I think we went over that one. That was from Mylek Hyman. I think we went over that one pretty extensively. It's a cleaner and an inhibitor. It's not, Fernox does make a glycol. It's a different product. But yeah, so here we go. One from Jim Hillpiper. How are you, Jim? Patrick, I'm replacing a cast iron boiler next week that has been noisy with the percolating noise. I drew a water sample and let it sit for several weeks, expecting iron to settle at the bottom, which did not happen. However, I've sold them on a system flush treatment as well as a magnetic filter. I'm all about solving an issue for the first time. So what would you recommend other than what I have?
Okay. If it's percolating, obviously the heat exchanger is fouled up. It's fouled up. The heat exchanger is dirty and the heat's not getting in the water, and that's what's causing the percolating noise. You could have, in all honesty, going back, hindsight, you could have offered just trying to clean the heat exchanger out. Hopefully it's an older boiler and needs to be replaced anyways. And obviously in that situation, I personally, with the product we represent, I would put the cleaner in there and let it run around in there for 2 to 5 days, get there, flush everything out, change that old system out, put the new system in, fill it with fresh water, and then at that point, I would put our inhibitor package in to prevent the new boiler from building up with whatever contaminants and particulates from the water that the old one did build up with. Because obviously there was something in that water that caused that unit to percolate and plug up and build up. And you want to make sure that the new system doesn't collect that. So.
Very good, very good. This one from Daniel Leary, testing a heat exchanger for
wait, can I expand on that one just a second? I also think, Jim wants to know he's is also thinking about maybe cleaning the system anyway, maybe not replacing it. So would the Fernex chemicals be able to help clean it?
Yeah, they have a cleaner that's available. It's called DS40. And I know I don't want to get too product specific. I appreciate everybody's time. But that product I've used on different heat exchangers out there. It's a magnificent product. It's an excellent heat exchanger cleaner. It's a citric-based acid cleaner, so you can get it on your hands and skin. You're not going to shed any skin, and it's not going to damage your heat exchanger. But in that specific system, you may want to, if you can isolate the heat exchanger, a lot of times I'll hook up to the boiler drain, and if there's shut-off valves, I may pull my relief on top of the boiler and put a boiler drain in there and flush that through that boiler that way. I actually had to do that in Watertown, Minnesota with a contractor on a couple Pinnacle 299s, and we got those boilers back online. It was the first time I ever used the cleaner, and it's excellent. But I will say, if you're using a heat exchanger cleaner, do not send it out into the heating system because you'll open up a can of worms. So,
Gotcha.
With that system, the first thing I would probably do is run a system cleaner in it. And then when I went back to flush all that out, I would try and isolate the boiler itself and flush the boiler heat exchanger and then fill it with fresh water would be the route I would go.
Okay. All right. So it could help clean it. Yeah.
Yeah. If you're not going to replace it,
right.
I'm all for boiler replacement. So
there you go. This is from Daniel Leary, testing a heat exchanger for deposits. Could you check the pressure? Could you check if the pressure drop will increase, or how do you test for a clogged heat exchanger? How do you know if it's clogged? I guess is the short answer. Short way to ask that question.
Very simply, exhaust temperatures. If I start getting high exhaust temperatures that are starting to climb, 30, 40 degrees above my return water temperatures, I know I'm not absorbing heat, right? And if the heat's not going in the water, where is it going? It's going out of the stack. It's doing that for one of two reasons. Either I have a lack of pumping, or I have a lack of, I've got a plugged up heat exchanger. It's that simple. Right. That's a test that whenever you're doing a boiler install, you should document your exhaust temperatures so that when you go back to do a service, you can look at that exhaust temperature and run it. And you can start to see if you're climbing on it at all. And that's a really good indicator of, do I need to clean that heat exchanger? Now, as far as the burner side of the heat exchanger, the telltale for cleaning the burner side is your condensate trap. If your condensate trap is full of garbage and dirt, you probably, in what looks like coffee grounds, which is actually pieces from your boiler system, you probably want to clean out that burner system and then figure out, why are you getting your corrosion? More than likely, you're recirculating flue gas. So I hope that answered the question.
Very good, excellent. Can you discuss water treatments for systems using 50% glycol?
Yeah, I'm not a huge fan, but if you're doing 50% glycol, number one, make sure that the boiler manufacturer allows it. There are quite a few boiler manufacturers that don't allow 50% glycol. Some of them have a maximum limit of 30%. So number one, if you're using 50% glycol, make sure that your boiler manufacturer allows it. And then, number two, depending on what glycol you're using, like I said, some of these glycols that are supposedly pre-mixed, you got to be really careful because some of it is settling out. Another reason I'm a big fan of the concentrate that we sell. We have a pre-mix, and it's an accurate pre-mix, but there's some out there that they tell you it's pre-mixed, but they really don't know where it's at. Another thing is, remember, when we add glycol, we're making a system less efficient. Anytime I put glycol in, I'm changing the specific heat and specific gravity of that fluid. It's no longer one like raw water is. So now to get the same amount of BTUs, I have to pump more gallons per minute. So those are things we need to address as well. And that's one of the reasons I always like to say, why do you think that at 80% boiler was now 65%. Well, what do you think the specific heat and specific gravity of this fluid is? It sure as hell isn't one, right?
Yeah,
So,
there you go. All right, let's see. How do you cure kettling in cast iron boilers? Guess that's same thing as percolating, right?
yeah, it's the exact same thing as percolating. The kettling is percolating, and you got a plugged up heat exchanger. Your heat's not getting in the water like it's supposed to. And you know, obviously, we're assuming we have proper flow.
All right, very good. I've seen techs using TSP for a couple of days. Thoughts?
Tech's using it. What was it? TST?
TSP. John, why don't you throw in an explanation? What exactly are we talking about with TSP?
Please elaborate on that a bit.
Yeah, okay. When I'm doing a new system that never worked, do I need to put cleaner or just the protection?
Honest answer to that is, are you using press? If you're using press, my honest opinion is you'll probably be fine treating it with just water. But if you are doing any type of sweating on that system with fluxes and residues, you're going to want to flush and clean that system out. There's so many systems out there today that, you know, are utilizing press and whatnot. But I will tell you, just not too long ago, I had a boiler strainer plug up on an in-floor system, brand new in-floor system, using press, and the boiler strainer was plugged up, and the boiler strainer was plugged up with pipe dope. And I found out that the young apprentice on there found that rather than taking the brush out of his container and brushing the fitting, he thought it was quicker to dip it in the jar and then screw it in. So when you can't make it up. When you consider those types of things,
it is faster that way.
yeah, it's faster. You may want to, you know, the true answer is, you know your work, you know how you're doing it. If you're using things that, you know, flux and thread sealants and things like that, and you're dirty with it, you probably want to flush it out. If you're neat and clean and the system is all pressed, fill it with fresh water and put it in the inhibitor. And this is my honest opinion.
All right, very good. From Mark Sheen, hardly ever see black water in Massachusetts. Over 99% of the boilers are not treated. Only see systems destroyed by antifreeze sometimes. Can you just add Fernox with antifreeze and be all set?
You can. Now, here's the thing that I learned just over Christmas. Some antifreeze manufacturers actually want their antifreeze to be at like a 9 to a 9.5. Well, the product I sell brings it to a 7, 7.5. Now, I've had people using my product for several years and have not had any issues, zero issues. But again, you kind of want to look at the manufacturer you're working with. So from my experience, I've had people using it, haven't had any issues at all. About the only issue I had was I had a couple contractors that were using standard glycol and then putting the Fernox F1 in it. And they weren't going back to recheck it. And the true answer is, if it was just our glycol, I'm not worried about it a bit. But when you're using others' glycol and you're putting that product in it to inhibit it, well, what happens when their inhibitor dies or goes bad? Do I have enough of my inhibitor to overcome that? And that was what we found, was when they're using inhibitors with other glycols, they still need to go back and recheck it, because when that inhibitor goes bad, that was initially in it, will I need to add more of my inhibitor to take care of that? I don't have a crystal ball for that.
Yeah. Here's one from our good friend Dan Cook. Please maintain the glycol in all boiler systems like we do in our cars and trucks. Most contractors do not know that they need to maintain glycol systems. This comes from a boiler guy. So yeah, this is now a way of life for us. You know, back 30 years ago when we were putting in cast iron boilers, well, we didn't need to be as concerned, but nowadays it's just a part of life. It has to be. And that's why I'm glad we were able to do this. Here's one from Jim Petreka. What about using the homeowner's RO or water softener to fill a system? Will that make the bad water good?
It's not going to make the bad water good. Remember, when you got to pick your poison. So depending on what you're doing, if it's not aluminum, filling a system with soft water versus bad mains hard water is probably a better choice. But just remember, if you've ever seen a foamed up system, soft water is going to introduce sodium and potassium to that system from the soft water, and that will in fact create a foamy system. There's certain chemicals and glycols out there that you can't add hard water to it, so you have to in fact add soft water to it. It's the only option you have. Again, one of the benefits of the product we represent is it's not an issue with us at all.
Very good. And RO water, really, for the amount of time it takes to create just a small amount of RO water, I'm not sure that would be a practical approach personally. Lots of black water and plugged drains in steam boilers. How do you treat that?
Well, there are, and that's the one, you hit me on my Achilles heel here. That's the one thing with the product we represent. We do not have a product to address steam boilers. There are products and cleaners out there that can address steam boilers. They're just not as turnkey and easy to work with as the product that we represent. But with steam boilers, there are products to clean them. We don't have any of those, so I'm not real familiar with the processes of doing that. My apologies on that. We have a very, very large industry, and it's hard to be an expert on everything. And
Right.
steam boilers is one that I've, in all honesty, just don't have the answers to that. I don't know, John, do you?
I remember back in the 80s when we do steam boilers, there were different chemicals that we would put in and let it run to treat the water and to help clean the system. It's been so long, I gotta be honest, I can't even remember what they are. I know a lot of different companies made them. Crest Good was a company that we bought a lot of different stuff with, and they had chemicals for steam boiler treatment. And boy, oh boy, there were a lot of them out there back then. And the years are playing games with my memory now. And I wish I could help. Dan, if you've got some information on that out there with Weil, please chime in. Terry Turner, how you doing? Terry asks, can you define low temp system relative to corrosion inhibitors?
Oh yeah, okay. So there's a bacteria that can be present in water. If any of you have a dog in a stainless steel dish, it kind of gets slimy in that dish. It's a very similar, if not the same, bacteria that can be present in water, and it becomes very active in warm water up to a certain temp. So basically, that bacteria can start to grow and create almost like a white, like a snot, like a slime inside of the system. I've seen pumps. Heck, I had one geo system out in South Dakota that if it existed, it looked like a Smurf turd. It was blue like a Smurf, and it was the solid of a turd that came out of the tube. And we ended up cleaning and flushing that system and used our glycol. And I have yet to hear back from the guy. It's worked out really well. But what happens is at low temperature, that bacteria can really thrive and start to grow and create like a snot, like a slime on there. Now, there's one way to kill that bacteria is you can get the boiler up above 140 degrees, and that will actually kill the bacteria. Unfortunately, with geosystems specifically, they just don't have the ability to do that. So a lot of times what we end up doing is flushing and cleaning those systems out and then introducing the glycol that we have, because the thing that's helping those that bacteria grow is the phosphorus bearing, the phosphates and the nitrates that help promote growth. And that's one of the things that the glycol we represent doesn't have, which makes it successful. There's some other bio cleaners that are available. We don't have one, but there are some that are available that can help kill that bacteria as well. I've had some old timers tell me that they've used bleach, and I certainly hope if you use bleach, you get it out of there, because I don't recommend that. But I've had people that have told me that kills that bacteria. To me, you've got two options: flush and clean it out and put a different glycol in, or somehow spike the temperature and kill it.
Very good. From George Conrad, in those test kits, how long do those reagents last?
Well, there should be expirations on it. It's going to vary from brand to brand. The test kits we have, that's a great question. The test kits we have, looking at one here right now.
And it also depends on the reagents too. I mean, some reagent is like I know just from taking care of the pool, for example, some of them will last forever and some of them are 1 year. So
Yeah.
it will depend on each individual one. Yeah.
It does. I know it does, but I'm not seeing it listed. Looking here to see if it's listed on the bottle. No. Actually, it's right on here. So this one that I have is fine. This one that I have here, which is a chloride reactant, this one expired 10th of October 2019. It's my sales sample. So, but it is listed on the bottle. Great question. That's the first time I've ever had that question. So excellent question.
All right, very good, very good. Does the clean and treat need to be done on a hot system?
What do you mean hot system?
Meaning up and running and the boilerating.
Oh yeah, okay. The cleaner, great. Okay, the cleaner is more active when the boiler is hot and running, but with our cleaner, it's not required. To me, the biggest thing is that the way our cleaner works is it has a hydrophilic and a hydrophobic. They bond together and form what are called micelles. Micelles float around in the system and grab dirt and grime and hold it in solution so that it can be flushed out. After 7 days, it loses that ability to hold it in solution. It'll actually start to fall back out. So that's how our cleaner works. Others that are out there, they may want it in for 5 days. They may want it in for 5 hours. It really depends on what you're using. So you can kind of look at the instructions there on that. Yeah, that's good question.
All right, Mark Davey asks, do you have a brand name of a test kit that would give us all three answers, the pH, the inhibitor level, and have a look at samples as well?
Fernox does have one that gives us those 3 test kits. They had the one that I have is an older one, and it has the copper and the full gamut. The newer test kit that's out there actually has less things that it can test for, but it focuses on those important ones that I kind of pointed out. And I'm sure there's others that are available from other manufacturers and other testing facilities.
Very good. And what's the issue with overdosing the inhibitor?
Well, if you put too much inhibitor in, you're going to raise your pH level, and you're going to become you're going to be alkalinity. You're going to become corrosive on the other end. Remember, inhibitor raises my pH. 7 is neutral. So if I put too much inhibitor in, now all of a sudden I'm corrosive the other way. So I need to put a neutralizer to bring it back down. That was the experience I had back when I was in the field and I treated that system. Was the stuff that we used, it had a limit. And the stuff that we represent today with the Fernox, I can't overdose with it. I mean, obviously, I wouldn't want to put 100% of it in, but the idea of putting too much in just isn't there with the stuff we represent, which makes it so much easier to work with.
Very good. All right. A lot of great questions here, guys. What's the difference between an exchanger cleaner and a system cleaner? Won't the system cleaner clean the heat exchanger? Asked Nick Sorrento.
Well, the difference is one is more aggressive and more corrosive than the other. Now, in most cases, out into your heating system, you want to clean it, but in some cases, when you start to look at threaded fittings and stuff like that, some of the buildup in there is actually preventing a leak from happening. So you wouldn't want to remove that and clean that. When you look at a boiler heat exchanger, you want a more aggressive cleaner to help clean that out. The true answer to your question is really how dirty is the heat exchanger? If that heat exchanger is just mildly dirty, we'll go ahead and use a system cleaner and it should be fine. But if you're getting percolating and you're getting flow issues, you're getting high exhaust temperatures, you probably want to clean the system and then address the heat exchanger separately after you clean the system. That's just, it really, the answer to your question is how dirty is that heat exchanger? So it kind of depends.
Oh, very good. Very good. Can you revisit the external cleaner for fireside heat exchanger surfaces?
Oh, absolutely. There's a cleaner available. It's called the DS10, Dry Side 10. It's a powder-based cleaner. You can put it in a little spray bottle and dilute it down with a spray bottle, and then just spray it inside of that heat exchanger and let it soak up and sit for a little bit to break down a lot of that buildup that we get inside of whether it be a fire tube or a Giannone style heat exchanger. And then you want to go in with some type of a non-abrasive brush, a nylon brush, and then, like I said, your wife's credit card, and go in and try and wear off that metal strip. but you want to go in between each one of those tubes on a Giannone heat exchanger so that the condensation that forms in that heat exchanger can drain out of that boiler and doesn't build up in there. A really good indicator on a Giannone style heat exchangers, when you take the front cover off, the front burner cover off, look at the white refractory. If there's a water line on that, the water's building up in that thing. More than likely, that heat exchanger looks pretty dirty and is in pretty rough shape. So that DS10, dry side 10, will actually, you spray that in there, let it soak in, and it really helps break down the buildup inside of that burner chamber so you can actually clean it. So.
Very good, very good. All right. When using a cleaner, do you recommend applying heat with it? We talked about that already. If I'm doing a combustion test, will I see if I need Fernox? I guess that's if the stack temperature has gone up since the last time you did it, then yeah, I think that would be an answer there for you. TSP, trisodium phosphate. Remember that question's come back as an inhibitor. Or for cleaning the system out, rather. Trisodium phosphate. I would think that phosphate, that's an inhibitor, right?
Trisodium phosphate, I believe, is a cleaner.
Okay.
And I think it's a pretty aggressive cleaner. Again, I'm not a fan of putting an aggressive cleaner out into the heating system. I'm just not. I don't want to put something out there that's going to create leaks. I've had a couple guys that have said they've used a heat exchanger cleaner in a system, and all I said is don't tell me that. I don't want to hear it because it's not my recommendation at all. I think that's kind of a nasty chemical to work with personally, but people use it. You know, there's a lot of things people do. I just personally, I like our cleaner better because, especially for a heating system, because I know it's not going to create any leaks.
Very good. All right. A lot more great comments. You have a new friend in Jim Hellpiper, Patrick.
Wonderful. Thank you.
Yeah.
Nice. It's always good to have friends.
Yeah. So sorry for him, because you know how anal I am. Andy Freeze wants 9 pH. How many boilers want that? Boiler companies want that as well. Yeah, we kind of discussed that. Not many.
I don't know a single one.
Right.
Everyone that I've looked up and checked out wants that between 6.5 and 8.5. Everyone I've looked up.
Right.
It's just that's what they're looking for, and I get it. Some of them are 6.6 to 8.5, but they're all right in that range. I actually had some chemical companies calling me and complaining about my product because it's 7, and they're saying they need to be 9. And I said, no, you need to be 9 for your chemical you're using. What's the recommendation on the mechanical system you're putting your chemical in? And I got kind of a blank stare. I said, well, to me, that's probably more important. If you're putting a chemical in that needs a 9, but you're putting it into a system that requires an 8.5 at a max, you're putting the wrong chemical in. It was an interesting conversation.
Yep, they usually are. Let's see. RO and soft water do not work. You want to fill the system with demineralized water after you have it cleaned, says Jeff House. Dan Slater says RO water is corrosive if you don't put in the right inhibitor. It's pure corrosive. Yeah, it's very corrosive. And again, yes. I wouldn't use RO water anyway because it takes so darn long to make just a small amount. I mean, what would the point be? Terry Turner asks, any suggestions for checking the inhibitor level when the manufacturer is not known?
Flush it, start over.
Yeah.
I'm serious. I've had so many guys that have tried to cut a corner, and let's just be honest with each other. I learned to quit cutting corners because I got so tired of being burned by it. Every time I cut a corner, personally, I'm saying, all right, I'll work for less, number one, because I'm cutting a corner, so I'm going to do it for less. Number two, I'm going to take responsibility for your whole system now because I cut a corner and made less. It made 0 sense to me. I get the question many times, hey, you know, the water kind of looks dirty, but it needs 500 gallons of glycol. Great. Flush the system out, sell them 500 gallons of glycol. Well, you know how much that's going to be? I do know how much that's going to be. I also know how much it's going to cost you if you cut the corner and then own that job. And that's just my life experience speaking there, but that's my life right there. Anytime I cut a corner, it always ended up costing me time and money, always.
Very good. Does the blue Smurfs not occur in snowmelt systems? The blue Smurfs. I'm going to remember that. That's the term of the night.
It probably could. I wish I had that picture yet. It was amazing.
Amazing. Yeah.
You know, snow melt systems, it really, low temperature systems, you can get that bacterial growth. I do believe that Geo system that had the blue Smurf thing, I think they were using windshield washer fluid, honestly.
That would do it. That doesn't help. Okay, here, from Jason Mangos, tell Patrick he hit it out of the park. He is the man on boiler manufacturer. He is the man as a boiler manufacturer. Everything he said is spot on. Your man from NTI gives
Thank
you
you.
thumbs,
Thank you
gives
very
you
much.
thumbs up. There you go. Oh, sorry, I just ran ahead here. Let me get back down to my questions. Oh, Dan Cook's chiming in on the steam boiler. I'm not a steam boiler matter expert, but the old way was to add TSP, trisodium phosphate, let it cook in the boiler for a few hours, and then drain the boiler, refill, and check the boiler water next season. Today we have modern steam boiler cleaners like Hercules, but Hercules, that was the brand name I couldn't think of. But please check on the label on all steam boiler cleaning chemicals. I'm not familiar with how to get all of the piping clean within the steam system. You are simply cleaning the boiler itself, not the system piping. One way to have a clean steam boiler, one may have to clean the steam boiler more than once if there's a lot of sludge in the system. Some systems take a long time to get dirty and can take a long time to get clean. Be patient. Be patient is kind of the watchword for steam, especially if you're cutting and threading a lot of pipe. You got a lot of oil in all that pipe. It eventually gets back in the boiler and you got to clean all that crap out. I mean, patience is a good word. I'm glad you brought up the name Hercules, Dan, because that rang a bell. That's the stuff that we would use. They had a specific steam boiler cleaner. It was like a powder almost that you put in there. It would be very foamy at first, but over time it would clean up. Oh, very good, very good. All righty. Can you talk a bit about Leak Seal?
Yeah, there's leak sealers out there. There's several out on the market. We have one that we represent through Fernox. It's called F4, and in a nutshell, it works. It works very well. I've gotten excellent feedback on it. You inject it into the system. One of the cans, let me see here. One of the express cans, similar to this, they'll treat, you know, up to 26 gallons, and you can't overdose with it. So if you had a 40-gallon system, throw 2 cans in, and that'll run around in the system. And once it finds a leak and starts to basically lose pressure, and I believe sees oxygen, it'll start to plug that leak up. It doesn't. I've had contractors use it on loop fields on low pressure geosystems, and it worked. I got good feedback. It does not plug up air eliminators or any of those devices on the hydronic systems. Over 7 years of repping this, I have gotten very, very good feedback on our leak sealer. Now, is it going to seal every leak out there? No, but if you can't find the leak and it's a slow leak, chances are this is going to fix that problem. I've gotten really good feedback on it. So Fernox does have a leak sealer that's available that we represent, and most of the time when I'm talking the product specific, I always bring that product up. But there are other leak sealers out there. You know, you probably want to find and get a track record on it. I'm not giving you a sales pitch at this point. I'm just telling you the contractors that have bought it have raved about it. They've said it's been a fantastic product and it's worked very well. It's worked on PEX, it's worked on Geo systems, it's worked on baseboard systems. I've had any system you could pretty much imagine. I've had people try it and it's worked on. I've got really good feedback on it.
Very good. Anthony Reichow is with us. Anthony says most manufacturers do not approve of trisodium phosphate, so that's good to know. Anthony also mentions that he met Donna Douglas once, who played Ellie Mae. And then the obvious question to follow up with was, how long was the restraining order in place there, Anthony? Well, hey, listen, you wouldn't be the first. All righty. Here's one last one. Are you familiar with Biona Bagel? Biona Bagel Bionabagel or Bionabagel? No, Bionabagel antifreeze or Bionable corrosion inhibitor used in the MZ boilers from Monitor. They claimed it would not deteriorate or weaken over time. We have many of these systems installed. So far, so good. Fingers and all other appendages crossed.
Well, cool. You know, there's a lot of options out there. And the thing that I like, the thing I've learned to focus on when I'm looking at other things, because somehow I end up having to, like, people will constantly tell me, well, they said it's as good as Fernox. Okay, fine. Then I need to look into it and make sure it is as good as Fernox. And there's a couple that are close, but the thing that I've learned to focus on, the big distinguishing factor is, number one, how hard of water can it be mixed with? Okay, what's the limitation of how hard the water can be mixed with on your glycol? Number two, how long is that inhibitor supposed to last? And then number three, probably most important, is what is the pH level of that? Is it within line of where your boiler manufacturer wants you to be? Remember, 7 and 7.5 is neutral. That's a perfect world. Okay, so when we're looking at other glycols, those are the things that I always want to look at. Is what's my limitation? How hard of water can I mix with that thing? And how long does the inhibitor last? And oh, by the way, and do I need to retreat it? And oh, by the way, you know, what do I have? What's my pH level when I'm at solution? And those are the three things that I think are very important with glycols. You know, and then you can get into mixture as well. You know, how pure is your mixture? If you say it's 40%, is it in fact 40%, or is it 70-30? And now I got to, you know, figure it out. Me myself, I'm a big fan with our product of the concentrate, because for me, when I've got 5 gallons of concentrate, that's easier math than trying to figure out, okay, I got a 70-30 mix, and now I need this. It just, to me, it bumbles it up a bit versus I know what I have and I know how many gallons I want in my system. If I want, you know, 20% glycol, this is how much I have to put in. You know, that to me, and then secondly, I'm kind of cheap. I don't like to spend money, and with the concentrate, I'm not buying anybody else's water. And remember, with the product we represent, well, it's true, and the product we represent can be used with pretty much any water you find. If you do get over with the product we represent, if you do get over the limit of how hard it can be, all you have to do is add additional inhibitor, that F1, you just have to add more to it.
Very good. There's still a lot more questions here, Patrick, so don't go away. We do want to answer the trivia question though, real quick. Now, remember, the question was, what was the name of the bank the Clampetts had their money deposited in, and what was the name of the bank president? Well, everybody knows the bank president. It was Milburn Drysdale, all right? Mr. Drysdale. The bank was the Commerce Bank of Beverly Hills. The Commerce Bank of Beverly Hills. So I know I did see an awful lot of guys get that question correct. So good on you, and we'll pick a winner next week on that trivia question. And I don't know, Dave, if you're ready to pick our winners from last week. But I tell you, when Patrick's gone a roll, man, this is good stuff. I mean, we had this is the best Q&A session I think we've had. So that is terrific. So
I wasn't getting in the way of that, man. I would have like lost a finger or something.
I know. Yeah, you just want to stay out of the way, keep your arms and legs inside the ride at all times, you know. So
seatbelt secured, yes.
Yeah, so next week everybody's gonna say, when can Patrick come back? We're tired of you guys. We want Patrick back. Yeah, that's you've created a monster, Patrick.
Wonderful.
All right, well, Dave, are you ready for the trivia question winner picker?
Yes, I am. I am all set.
All right, well, I'm making you the presenter.
Okay.
Jethro.
Okay. And the first trivia, so we're giving away 2 gifts tonight. So the first one was about the what the heat loss was. So those of you that had done your homework and actually threw the answers up on the board last week and got close, I know there was some variations and we took that into account on some of those things. So the first trivia, these are the answers for those people, or these are the people that answered it properly. and I will be sending out a Takeo backpack, Carhartt backpack here. So I think we should probably
Very
send one to
nice.
Patrick now. It looks like he wants one now too, right? So
Oh, that's nice.
I think you've earned it. You've definitely earned it, Patrick.
but he didn't
I
do his homework.
appreciate
So
I appreciate the opportunity.
all right. So John Randall. John Randall is the winner of the backpack. I will be sending that out to you, John. I'll get your email and I'll shoot you an email to get an address from you.
It's not the Minnesota Viking, is it?
Not that John Randall, no.
No, not that one. Nope. And so the next one was based upon our questions from last week, the trivia question last week. We didn't get a lot of answers. It was a tough one. It was the name of the band that Marty McFly had started in the garage band, and also who was the teacher that told him his music was too loud. And the answer
Who was the
Pinheads.
actor who played the teacher?
Actor. Sorry, yes, the actor.
Who played the teacher that told him, boys, you're just too darn loud?
Right.
The name of the
So
band
we
was
had-
the Pinheads.
Mm-hmm.
And the actor who played the teacher wasn't really an actor. It was Huey Lewis from Huey Lewis and the News, which is interesting because they used Huey Lewis songs as part of the soundtrack.
So here's the winner of that. And it looks like it's going to be Mr. Bill.
All right, Bill.
And for that,
Congratulations, Bill.
I got a whole bunch of stuff actually thrown in the bag that I will be taking out and sending over to you. So a whole bunch of other
Excellent.
Takeo gear, hats,
That's the one you
koozies,
want, right?
things like that. So yes.
Excellent. All right. Very good. Very good. All right. I'm going to take the con back here and let's go with some more. Patrick, you want to handle some more questions? Are you good?
No, yeah.
All right. Because there's a bunch. There's most definitely a bunch. Let's see. We, Biana Bagel, we went through that one. Where are we at here? On leak sealers, you have to be aware of the type that uses silicates, as it will crystallize on impellers and valves. There's a very good point. You don't want anything getting on an impeller, definitely. Dan Cook talking about, again, we're back to cleaning steam boilers. Dan, thank you for this input. This is awesome. Every time one cuts and threads piping, the oils from the piping will return back to the boiler, and the boiler will have to be skimmed to remove the oils on the surface of the water. The boiler may have to be skimmed more than once, and now the patience is critical. We use vegetable oil in our manufacturing process to cut and thread the boiler, the boiler sections. Therefore, the oils come from the cutting and the threading of pipes. Thanks for mentioning the cutting and threading of pipes. Repairs to a steam system will require skimming of the boiler and possibly more than once. Patience, patience, patience with steam boilers. Oh, patience with steam boilers. And they'll try your patience. They most definitely will. Okay, the leak stopper you talked about, for what kind of pipe is it? That's from Milek Hyman.
Anything. PEX, aluminum, cast iron, stainless steel. It works with anything.
Very good, very good. John Allen says he received the Takeo 007E. He won a few weeks ago. Excellent, excellent. Bill, congratulations. Bill chimed in. Okay. John did okay with Aquastat, but we prefer to have Jethro say it once.
Well,
Mr. Hill Piper.
The Aquastat along with my coffee.
An Aquastat. Does that make you feel better, James? It's an Aquastat.
He wants the New Yorker in me to come out.
Get your Aquastat right here.
Yeah, we'll go hang out and have some coffee and water.
There you go. There you go. Hey. And Fafangul is Italian for have a nice day, all right? All right. Jim Petreka says, great job. Thank you. He's leaving a smarter man. Oh, that's terrific. Jeff House says good night. Jim DePalma says good night. I think oh boy, hey, we caught up with all our questions. So folks, last call. Any other questions you have on the topic tonight? Or any other topic you guys want? I mean, like I said, we will be here as long as you folk have questions, because as you've surmised, Dave and I have no lives. All right, this is the high point of our week. Patrick is joining us out of the goodness of his heart, but Dave and I, we have no friends, we have no life. This is our only communication with the outside world. So Joseph asks, how often do we test the water?
You really should test it once a year. Even if you're using my product, you should check the water once a year. You should go back and do annual maintenance on a boiler once a year. You should be checking the water. It's good practice. It's the right thing to do. Oftentimes I kind of chuckle because some reps will tell contractors, well, with our boiler, it's condensing boiler, but you just the first year, look at the condensate trap. And if it's really not dirty, you might not have to go back there for 2 or 3 years. And I always kind of think that that's probably the worst advice to give someone, because what do we know about condensing appliances? What do they all have in them? A condensate trap. What happens if that condensate trap gets plugged up? That appliance just doesn't work very well at all. We need to go back at a bare bones minimum. We got to go back and clean the condensate trap at least once a year. Get there and clean it once a year. While I'm there, why don't I check some of the other things? And along with what I'm checking, let's check the boiler water quality and just check it out. Fortunately, the product I represent, you should not have to recondition the inhibitor. The inhibitor should still be sound and solid. But it does say in the instructions you get a check. Pretty much every boiler chemical that I know of wants an annual check. The reality is we need to do a better job of maintaining these systems so they last 15 to 20 years like they're supposed to. I always chuckle because I hear people saying, I'd never put a condensing boiler in because they don't last. Well, how do you set your gas pressure up? Well, I just put them in. Okay, how do you size your pumps? I just put the pump in that it came with. Oh, okay. Looking at boiler water quality? Well, no, I don't have to. Well, I'm sure your boilers are lasting 5 years. That makes sense. But if you're doing your job right, these systems can and will last. And then last but not least, the question I always ask that person that says they don't last is, are you maintaining them? Are you going in and checking those systems out like you're supposed to? Oh, no. Well, then, yeah, you're right. They probably won't last if we're not taking care of and service them. So the reality is we should be going back annually to check specifically condensing boilers. And while we're there, I'd like you to check the water quality. I think it's good practice.
Very good. Very good. All right. Let's see. Where can I call for more info? Asked Malik. I would start with your local wholesalers, Malik, and then Fernox. You can look up Fernox online, and they'll be able to. That'd be where I would start personally. And Jethro just gave you some information there, which is perfect. All right, excellent. Another one from Dan Cook. This is for you, Patrick. Thank you for the water treatment discussion. I learned a nugget or two that might use those nuggets in my next training classes. My standing joke each week: when something goes wrong with the system, always blame the boiler. There you go. Seriously, boiler water quality is key to maintaining and increasing a system's life, especially high efficiency boilers. Absolutely, absolutely. All righty, yeah, it's a different world. I learned that early on with ModCon boilers. It's a very, very different world than the old cast iron days. Because what did they call Dave? What did they call the legs going down to the wet base? What do they call those things?
Oh, the mud drum.
Yeah, they were called mud legs, right? Or mud
Yeah.
drums. That's where all the crap would gather, and that's just where it was. Well, ModCon boilers don't have those, all right? They just don't have those. And it's a way of life. You have to think differently. You have to clean them. They're made out of different materials. It's not a cast iron heat exchanger. It's aluminum or stainless steel. You got to take care of them. They're just not the same animal that we were used to. It was like going from a automatic transmission or standard transmission to an automatic transmission or to fuel injection. I mean, everything moves forward, and it needs to be, you have new maintenance that needs to be looked at. And again, a lot of guys, that's coming home to roost. And I think it started when the boiler manufacturers started to say, enough, we're not going to be warrantying heat exchangers where we know the water hasn't been treated, and we know where the water hasn't been treated, So they know that. Then that once that started, I think it was that wake up call. You can't say, well, screw you, I'm going to go use somebody else's boiler. Well, it happens with them. You're starting to run out of boilers to go to, right? So you got to. It's the way life is, and that's how it works. and it's a good thing. You know, it's a good thing. All righty. Patrick, George Conrad has the Fernox power flushing unit, and he says it's awesome to use. Very good. And like Bill Chanel says, like anything else, as you increase your efficiency, the margin of error gets less and less. This is true with all types of products: cars, scorched air furnaces, boilers, etc. Oh, absolutely. We had this discussion last week about radiant floor heating. You know, when you and it's kind of the opposite actually. Is when you start getting rid of mass, like going from a slab installation to a thin slab, or a thin slab to between the joists with plates, or between the joists with plates to suspended to between the joists. As you remove mass, your margin for error gets smaller and smaller and smaller, and you have to do the math. It's just the way it is. With products like this, there is no margin. It's not really a margin for error. It's just this is you got to do it. Nobody squawks about changing their oil every 3,000 miles, right? Why would you squawk about checking the water quality every year and putting in place a water treatment protocol? Because as you pointed out earlier, Patrick, it's part of the service that you provide. And if you're going to sell a service contract or have some sort of a service deal, well, you got to do something, right? You know, and this is a huge part of it, because then you can actually express and show in dollars and cents the actual value of all this. So it just seems to make sense. Here's from Joseph Walkerden: to show you the level of maintenance in hydro systems in Victoria, Australia. Where there are no Fernox test kits in the country, had to order one, and it has now been 8, and I'm still waiting. Obviously, maintenance is minimal here. Great session, guys. Good day,
Well,
mate.
yeah. I mean, just like, you know, just because we didn't do a lot of it in the past doesn't mean we shouldn't do it now, because we can't unknow this stuff.
Yep.
Right. So it's
You
now
can
that
ignore
we
it,
know.
you can't unknow it.
Yeah, now that we know it, you can't ignore it. Exactly. So and we want to, you know, hey, those of us that love doing this hydronic stuff, you know, it's, you know, what do we hear? It's a small part of the industry right now, and we want to keep it going because we know how good it is, and we know how enjoyable it is, and also how profitable it can be too at the same time. But we got to keep them going. You know, we want to still perpetuate the hydronic systems that are out there. So make them as best as you can, and that's the way I look at it. So.
Yep. And here's one from Dan Cook: I recommend using inhibitors in all boiler systems, even cast iron boilers. I'm sure Patrick would agree that we must learn how to clean, maintain, and protect boiler water in all systems, whether the system is cast iron, copper tubing, or whatever. True story. Absolutely. I couldn't agree more with you, Dan.
100% agree with that. Absolutely.
All righty. Well, it looks like we're hitting the end of the questions here, guys. Last call. It's 9 o'clock out here in the East Coast. All right. Phil May says he's going to watch the episode again on the recording. Patrick was great. Hey, now everybody, like I said, next week, where's Patrick, man? We're tired of you guys. It's going to be the cult of Patrick. I think it's what we've created here, the cult of Patrick. You're going to have followers now. You know that, don't you?
Oh, I hope not.
Oh God, everybody. So while this is going on, your Instagram, LinkedIn, and Facebook page has just been getting hammered.
Oh, wonderful.
Yeah.
I have not had them on in quite a while.
Well, you better check, man. You better check.
Yeah.
And are you on Twitter?
Yeah, I am. Yeah.
You are. I didn't know you were on Twitter. Oh, very good.
Well, I will share that with you.
All right. Cool. All right. Well, folks, thank you all again. Really appreciate the gift of your time, as always. And again, you'll be getting some follow-up stuff from us tomorrow with links to recordings and certificates of attendance. And Dan Cook's going to get some black raspberry chocolate ice cream. That's the ice cream of the day. Every
There it is.
Every Wednesday, Dan hits the ice cream after the show. So that's terrific. Very good.
Tell him I said hey over there, Dan.
Black raspberry chocolate. That, to me, if it ice cream, anything with any ice cream with peanut butter on it, you know, had me at hello. All right. I'll buy it a car. That's how much I love ice cream with peanut butter. All right. You could, well, technically you could put peanut butter on anything and I'll love it. You could put it on a shoe and I'll enjoy it. That's how much I love peanut butter. By sharing a little too much. Okay, there we go.
Okay. Yeah. So anyways, everybody out there, in case you want to watch this again, obviously it's going to be on Mechanical Hub's YouTube page. It's also going to be on our YouTube page. So you'll, like I said, you'll get those links in the email next week or tomorrow, I'm sorry. And look for them uploaded on the websites if you wanted to watch it again or you wanted to share it with anybody that didn't get to make it tonight. Remember, next Wednesday, we'll be doing this again. And we'll look forward to re-register again. It's another registration, so you'll get that registration also in the email tomorrow. So thank you again for coming and hanging with us tonight. Greatly appreciate it.
And thank you, Patrick. Hats off, brother. Well done.
Thank you very much. It was a lot of fun. So thanks for the invite. Thank you. Thank you.
I'm not worthy.
We're not worthy. We're not worthy.
Who do I learn from, Johnny?
And I've never said that to a guy wearing a Golden Girls t-shirt before. I want you to know that.
It says stay golden. It was my kid gave it to me for my 40th birthday, and he thought it was so funny. Stay golden.
That's what we love about kids.
Uh-huh. Yeah.
All righty. Well, thank you, everybody. Patrick, take care. Dave, we'll see you soon.
Enjoy, y'all.
Uncle Jed saying so long.